Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Maths ratio calculations. Now, in a previous maths video we have looked at the ratios, but we looked at the basics and like I said, we haven't covered everything. So we are basically just going to carry on with the GCSE ratios and I'm going to show you some more stuff that you should know. Okay. So without further ado, let's get started. So, first thing we need to cover is proportional division. Now, what does that mean? That basically, long story short, that basically means how to convert ratios into actual numbers, how to divide ratios up onto each part. Now, I will tell you what it means. If the best way to show this is through an example, I think, and you will see what I mean by it. Okay, so here we have an example. We have two thieves that did a heist on a bank and they managed to steal 20 rare golden coins. There's 20 of them drawn out here. Now, because of their previous arrangements, they decided to split those coins between themselves, those 20 coins between themselves, in a 2-to-3 ratio. Now, the question is, how many coins each of those thieves gets? Okay, how do we work this out? Well, the first thing we need to do is, we know that the thieves split it between themselves in 2-to-3 ratio. Now, what we need to know is what in those 2-to-3, what in those ratios 1 means, essentially. Because that means this thief gets 2 parts, this thief gets 3 parts. But what is 1 part equal to? That's our question. That's the first thing we need to work out. What 1 part is equal to. And we do this by adding these two up. So we get total number of parts. And we just divide those coins by the total number of parts. So we add these two up. So 2 plus 3 is equal to 5. So then what we do is we need to find out what 1 part is equal to. So we get those 20 coins, 20, and we divide it by the total number of parts to give us what 1 part is equal to. So we do 20 divided by 5, which is equal to 4. So 1 part is equal to 4. So that's the very first step that you need to do. Now we know what 1 part is equal to, so now it's all downhill. Now it's pretty easy. We just have to figure out what those, multiply these up to figure out what those thieves actually get. So this thief gets 2 parts. 1 part is 4, so let's just call it thief 1. Okay. So we have 2 parts and 1 part is equal to 4. So 2 times 4 is equal to 8. So thief 1 gets 8. And I'm going to underline that. That's our answer for thief 1. And thief 2 gets 3 parts. So what does that mean? We need to multiply 3 times 4. So 3 times 4 means that thief 2 gets 12 coins. And that's our answer for thief 2. Now, if we added 12 plus 8, then we would get 20. So we can check, this way we can check that all of these coins have been divided up, that we've done this correctly, and we divided the coins up correctly. So thief 1 gets 8 coins and thief 2 gets 12 coins. And that's how it works. So on the picture here we would have 1, 2, 3, 4, 5, 6, 7, 8. Like so. So that's thief 1. And then the other 12 coins go to thief 2. There we go. So that's how we do proportional division. Proportional division essentially is its fancy word for dividing up the items according to the ratio that we are given. That's all it means. That's all it means, and that's how we do it. Anything, even if you say had 3 thieves and you had another ratio here, you do it exactly the same way. You add all of these up to find what one part is equal to, and then knowing what one part is equal to, you multiply out accordingly for the different parts that each thief would get in this case. So that's the basic sort of algorithm, if you will. That's how you work out proportional division. And that's very, very, very good because understanding this, we can move on to the next things that we need to know. Okay, so now let's move on to the next thing. Okay, so the next thing we need to cover is whole ratios. What does whole ratio mean? Whole ratio means that the ratio we given is a part of the whole. So we don't have that sort of split. I will show you on a picture what I mean. It's best explained on a picture. So here we have, say, 2 people selling lemonades. And in total, they sold 6 lemonades, as shown on a picture. So in total, 6 lemonades have been sold. And person 1 sold the lemonades in a ratio of 4 lemonades to the total of 6 lemonades sold. So what it means is that person 1 sold these 4 lemonades, whereas person 2 sold the rest. And the total is 6 lemonades. So that's the difference. So if that was a normal ratio, the total would be 10 because we would have 4 to 6. So the total would be 10 because we would be adding those up like we did in the previous example. However, because that's a whole ratio, that's 6 is a total. That 6 is a total. And this is very important to read your questions very carefully because that's a very, very easy way you could be cut out. When people say that this is a whole ratio and you treat it as a normal ratio. This is very immensely important because so many people have been cut out on this. So how do we deal with whole ratios? Here is a fairly simple example, but how would we deal with a whole ratio where we can't see it obviously in our head? How would we deal with such a whole ratio? Now, the way to deal with this is, I think the easiest way to do this is to convert the whole ratio into a normal ratio and then just work as you would normally. I think that's the most sensible thing to do. So, how do we do this? Well, we know that 6 is a total. We know that. So, what we have to do is, we have to find out the other part. We know that one part of it is 4. But here we have a total. We don't know what the other part is in theory. Obviously, you can probably see it, but in theory, we don't know what the other part is. We know total and we know one part. So to find the other part, we just do 6 minus 4. We take that away. We take that 4 away from the 6 total, leaving us logically, that will leave us the second part. So 6 minus 4 is equal to 2. And that's our other part. So our normal ratio, converting this to our normal ratio, it would be 4 to 2. And then we can work as normal. This is our normal ratio, as I like to call it. That's our answer. And then you could work as normal. You could shorten it. You could, if they sold more lemonades, you could figure out by proportional division how many lemonade each person sold. You just work as you would normally. Okay. So the final thing that we need to cover for today is scaling up. This is more of a trick. This is a useful trick sometimes, because this sometimes can help you avoid doing the whole proportional division. This helps you avoid finding one part and then multiplying everything out to find what each person gets. This is a little trick to sort of help you along. Sometimes it can be a useful shortcut. It doesn't always work, but when it does work, it can be a useful shortcut. So what do we mean here? Well, I'll show you in an example. That's the best way, I think. So let's think about this. We have a doggy daycare. And in doggy daycare, we have big dogs and we have small dogs. Now, we know that we have a ratio of 5 big dogs to 3 small dogs. And we know that we have 15 big dogs. The question is how many small dogs do we have? That's our question. So we can do this the normal way. We can do the proportional division, or we can do this really quickly by scaling up. Now, the same way we can shorten, like in the previous video, the same way we can shorten the ratios by dividing both sides by the same amount, we can scale up ratios by multiplying both sides by the same amount. So in this case, we can see that our ratio is 5 to 3, but we want to achieve 15 big dogs. So we want to scale up ratios so it will be 15 to something, and that will give us the direct answer. Now we can see that if we multiply the 5 by 3, we're gonna get 15. So we're gonna do just that. We multiply this side by 3. And because we're scaling up, we have to do the same to the other side. So we multiply 3 times 3, and that will give us the number of small dogs, which is, of course, 9. So this is our answer. So we have 9 small dogs. 9 small. And as you can see here, we just did it in a single step instead of this kind of 3 steps that you need to take when you're doing the proportional division method. So this is a nice shortcut sometimes. So this is it for today, guys. I hope this video helped you immensely. If you liked this video, give me a big old thumbs up. If you want to stay up to date on daily math, science and some biomedical science videos, hit the subscribe button below. And if you have any questions whatsoever, shoot me a comment. I'm more than happy to help you guys out. Thank you for watching. I really appreciate whenever you guys watch these videos, and see you next time.